Conventional roof framing has long been the backbone of residential construction in the United States. In this system, rafters, ceiling joists, and ridge boards come together to form a simple but highly effective structural framework for gable roofs. While the rafters provide the sloping members that define the gable roof's profile, additional horizontal elements are required to complete the load path and ensure stability. These include ceiling joists and alternatives such as rafter ties. Other critical elements include collar ties and alternatives such as ridge straps. Rafter ties and collar ties are frequently confused in practice and in online discussions. However, they serve very different and distinct purposes within the roof assembly, with each of them addressing distinct structural needs. Therefore, before delving into the detailed requirements of rafter ties and collar ties as outlined in the IRC, it is essential to first recognize their place in the overall framing strategy and their contribution to maintaining a complete and dependable load path. At its core, conventional framing is designed to create a continuous and reliable load path that transfers roof loads, including dead loads, live loads, snow loads, and wind loads, safely down to the foundation. The rafters support vertical loads and translate them into both vertical and horizontal reactions at the supporting walls. Since the supporting wood-framed bearing walls are not designed to offer support against the horizontal thrust forces from the rafters, ceiling joists are used to tie the rafters together and resist this outward thrust. For cases where ceiling joists are framed perpendicular to the rafters or are not continuous between opposing rafters, the code requires rafter ties or other approved alternatives to tie the rafters against the outward thrust forces. On the other hand, collar ties function in the upper portion of the roof framework. Collar ties are used to resist separation of rafters near the ridge under wind uplift loads. Alternatives such as ridge straps can be used in place of collar ties, but the function remains to ensure that the roof remains intact under wind uplift loading. Understanding the distinction between rafter ties and collar ties, and the forces they are meant to resist, is critical to applying the code requirements correctly. In this video, we will explore code requirements for the framing of rafter ties and collar ties. According to Section R 802.5.2, rafter ties are required to be installed where ceiling joists cannot fulfill the requirement of tying the roof rafters together. We have noted that this includes cases where ceiling joists are perpendicular to the rafter. In such a case, ceiling joists will be framed perpendicular to the rafters and rafter ties will be installed above the ceiling joists but not higher than 1/3 of the height of the attic. In conventional framing, ceiling joists have two functions. First, ceiling joists need to support the live loads and dead loads at the ceiling and to provide continuous ties to resist the outward thrust at the base of the rafter. On the other hand, the role of rafter ties is to resist the outward thrust where ceiling joists cannot perform this function. Due to these differences, sizing ceiling joists is very different from sizing rafter ties. The process of sizing ceiling joists is mainly driven by their role in supporting gravity loads, while the minimum size of rafter ties is prescriptively fixed by code for all cases. This is because the minimum section size of rafter ties that is provided prescriptively in the code is based on its ability to resist the tensile thrust forces, which are not high when compared to the capacity of the section used. Section R 802.5.2.2 specifies that rafter ties must be made of at least 2 inches by 4 inches nominal wood and installed in the lower third of the rafter height, which ensures that they remain effective in tension under the horizontal forces exerted by roof loads. They are required to be spaced at a maximum of 24 inches on center. Since rafters are typically spaced at 24 inches on center, rafter ties are therefore required on every rafter pair, thereby providing continuous restraint along the length of the roof. Even for cases where roof rafters are spaced at 16 inches on center, rafter ties will need to be provided at 16 inches on center because the closest alternative is to provide them at 32 inches on center, which is not acceptable. We have said that rafter ties can be installed anywhere within the bottom third of the attic. They are restricted to remain within this zone because the amount of tensile force they will be subjected to varies with their position. Even within this 1/3 zone, the amount of force varies significantly and has a direct influence on the number of fasteners that are required to attach the rafter ties to the rafters. Let us consider an example of an attic that is 6 feet in total height. Ceiling joists or rafter ties are permitted to be installed anywhere in the bottom 1/3 of the attic space. This is equivalent to the bottom 2 feet of the attic space. This means that the height of the bottom surface of the rafter ties cannot be more than 2 feet from the top of the top plates at the bearing walls. If ceiling joists are installed at the base of the attic and are attached to the rafters, then no rafter ties are needed because the ceiling joists are tying the rafters together against lateral thrust forces. However, if ceiling joists are raised above the base but installed within the bottom 1/3 of the attic space, which in this example is within the bottom 2 feet of the attic space, then the tensile force in the ceiling joists will increase proportionally. Similarly, if ceiling joists are perpendicular to the direction of the rafters and rafter ties are needed above the joists to tie the rafters together, the force in the rafter ties will increase with their height above the attic space. The higher the rafter ties or ceiling joists are raised up the attic, the higher the tensile force demand on them and their connections. The code recognizes this fact by providing adjustment to the amount of nailing required between ceiling joists or rafter ties that are raised above the attic space and the rafters they are attached to. First, ceiling joists that are attached to rafters at the base of the attic space are required to be fastened according to Table 1 of Section R 802.5.2. Let us assume that the rafters in our example have a slope of 4 to 12, with a roof span of 36 feet and a roof live load of 20 pounds per square foot. In this case, the heel connection at the base of the attic requires 11 16-penny nails per heel joint connection. If the ceiling joists are raised 1 foot above the base of the attic space, or if ceiling joists are perpendicular to the rafters and we need to attach rafter ties 1 foot above the base of the attic, then the tensile force will increase. Therefore, we are required to adjust the heel joint connection requirements according to the adjustment factors provided in Table 2 of Section R 802.5.2. This table has 2 columns. The first column is a ratio of 2 factors, HC and HR, while the second column is the adjustment factor. HC is the height of the ceiling joists or rafter ties measured vertically from the top of the rafter support walls to the bottom of the ceiling joists or rafter ties. HR is the height of the roof ridge measured vertically from the top of the rafter support walls to the bottom of the ridge. Therefore, if the ceiling joists are placed 1 foot above the top of the bearing wall top plates and the ridge height is 6 feet, then the HC over HR ratio is 1/6. This means that the adjustment factor is 1.2, which represents a 20% increase. Since we needed 11 16-penny nails for ceiling joists attached at the base of the rafters, this connection will need to be bumped up by 20% for ceiling joists or rafter ties that are 1 foot above the top of the bearing wall top plates. The required nails are 1.2 times 11, which is 13.2, which should be rounded up to 14 nails. Therefore, we need at least 14 16-penny common nails at this connection. This is how the connection between rafter ties or ceiling joists to the rafters is designed to resist the outward thrust forces at the base of the rafters. Let us now turn our attention to collar ties. Collar ties or ridge straps are required in conventional framing to prevent separation of opposing rafters at the ridge. Unlike rafter ties, which resist outward thrust at the base of the rafters, collar ties address forces near the ridge, particularly uplift from wind that can cause rafters to pull apart at their upper ends. The requirements for collar ties are provided in Section R 802.4.6. Collar ties are required to be installed within the upper 1/3 of the attic space and spaced not more than 4 feet on center. Lumber collar ties must be at least 1 inch by 4 inches in nominal dimensions and should be face nailed to the rafters according to the requirements in Item 5 of Table 1 in Section R602.3, which is also known as the fastening schedule. The schedule offers 3 options for attaching collar ties to rafters. The first option requires 4 10-penny box nails. The second option requires 3 10-penny common nails, and the last option requires 4 3-inch by 0.131-inch diameter nails. Any of these fasteners may be applied to attach the end of each collar tie to the rafters. The code also permits the use of metal ridge straps as an alternative to collar ties. Ridge straps must be no less than 1 1/4 inch wide by 20 gauge thick. Each strap is installed on the top face of the rafters and ties the 2 opposing rafters to prevent separation. The strap should be nailed to each rafter with no fewer than 3 10-penny common nails, and the closest nail to the end of the rafter should not be less than 2 3/8 of an inch from the end of the rafter. It is important for a designer using proprietary straps to ensure that the width and gauge of the strap is not less than the requirements that we have noted. Additionally, when drafting construction drawings, the designer should specify the model and type of the strap if they are using proprietary straps, the number of nails required to attach the strap to each rafter, the length of the strap, and the distance between the first nail and the end of the rafter. Whether collar ties or ridge straps are used, the goal is to keep the ridge intact and ensure that opposing rafters remain tied together under varying load conditions. By securing the rafters at their uppermost points, collar ties or ridge straps complete an essential part of the load path, ensuring that the roof framing acts as a unified system capable of resisting upward suction from wind. Thanks for watching, and if you'd like more training on conventional construction, please check out www.conventionalframing.com. If you found this video helpful, be sure to like, subscribe, and stay tuned for more insights into wood framing.